All right, welcome everybody. I hope everyone can see the intro slide. My name is Glenn Andrew, and today I'll be going over the new features of SimCenter STAR-CCM Plus version 2022.1. And I think we're just going to go ahead and get started because I have a few intro slides, and probably by the end of these, everyone will be here. All right, so today we have a few things, or a few high-level topics to run through. I'll first start off with a background of Structures.aero, and then we'll dive into the new features. And some of these new features are GPU acceleration for fluid flow simulations. That's a highly requested user feature and a big deal for Siemens, as well as our customers. We'll cover a new Aeroacoustics physics model, and then discuss the new simulation template file type, and also talk through a little bit of the new fluid structure interaction model with the introduction of the deformable body contact models. And then we'll also talk through the STAR-CCM Plus Web Viewer. I think that's a big new feature, at least for me. And then we'll talk about the new implicit volume of fluid multi-stepping methods and improvements there. And then also discuss some miscellaneous updates that I thought were pretty interesting and cool and exciting about this new update. So a little bit about us first. Structures.aero is an engineering services company as well as a software company. So we have 22 engineers. Most of us just have a bachelor's degree, and we mainly comprise of aerospace and mechanical engineering majors and a few engineering science and mechanics. Some of our recent projects have been pretty broad across the industry, across several industries actually. We cover space, aircraft, UAVs, and several other projects. Currently, some of those highlights are working on the Dream Chaser program, working with Boom on XB1, their supersonic demonstrator. And then we also do a lot of work on unmanned aerial vehicles, mostly commercial. And we also just help out anyone who needs help. And a couple examples of these, we've worked with a couple dredging companies as well as manufacturers producing ground air support equipment for airports. So the other side of our business is SDA Software, and we are a Siemens value-added reseller. So we sell a lot of Siemens software, and we also support this software. So obviously we sell STAR-CCM Plus, but we also sell Femap coupled with NX Nastran, or SimCenter 3D coupled with NX Nastran, and then several other software platforms such as Fibersim, and the other big one is HEEDS for optimization. And one of the big things that we, the value added part is that we also support this software. So whenever anyone has a question or basically an inquiry like, how do I do this? Or, I'm having a licensing issue, we're kind of the first line of support there. And we help get back to our customers quickly and help them get, fix their licensing issues or maybe debug a simulation here and there. And then after that, if we don't know the answer, we have a direct line to Siemens and the software writers. So if there's an actual bug, we can actually help get those fixed really quickly for the new versions. And then also, if we don't know the answer to technical questions, we have access to technical experts on the Siemens side to help resolve those as well. All right. Let's dive into some of the new exciting release highlights of SimCenter STAR-CCM Plus. And I guess before we dive straight in, I do want to note that these are just the highlights. I think this slideshow is 23 slides long, so probably about 15 or 20 slides of highlights. But the actual detailed highlights PowerPoint is, I think, I looked through the whole thing and it's about 150 slides long. So there's a lot of updates in this version. So I would really highly recommend potentially accessing that and skimming through to see if there's anything that directly applies to your simulations. Because I know there's updates on the user interface side, as well as all the models, physics models as well. So the first thing that we're really going to talk about here is GPU acceleration of fluid flows. Basically, this is a highly user-requested feature, and it enables faster simulations, and it enables lower simulation costs. So this is really exciting and something that I know Siemens is focusing on in the future, not just with this initial release. It's valid for the segregated solver with steady and unsteady simulations. It works with most turbulence models. It works with constant density simulations, and we'll touch on that more in a sec, as well as it supports most standard reports and field functions. So one pretty major limitation at the moment is that this is only valid for, or it only works for the constant density physics model right now. And the reason that is just because a lot of these algorithms and solution sequences have to be almost rewritten, or at least ported over to be able to run on a GPU architecture. So it's kind of going to be an iterative process to roll out some of the more complicated models. But what this really means is that it's good for ground vehicle aerodynamics and anything that's like fairly slow. Slow is in probably under 0.3 Mach. And the other big thing to mention here is that there is a new license that's coming out that supports GPUs. But if you have any questions about that, I think Siemens will be kind of coming out with more information on how the licensing works for this. The big takeaway, though, is that on 8 of NVIDIA's V100 GPUs, that was about equivalent in terms of the average iteration time to 29 Xeon Gold nodes. So a Gold node has 40 cores. So basically, these are 2 different clusters that are equivalent in the amount of processing power. And the key takeaways here are that this GPU cluster was 40% of the hardware cost of the CPU cluster, and it only consumed 10% of the power. So that's a huge improvement, and something that I think everybody's really excited about. Okay, so the next thing is an improvement for Aeroacoustics. Siemens has rolled out a new perturbed convective wave model, and basically what this is used for is short distance aeroacoustics simulations. Basically, in this situation, it's where noise from a side view mirror is reaching someone in the driver's seat. And the improvement here is that it reduces the simulation time and allows you to use a coarser mesh and larger time steps. And then it also has improved accuracy in the high frequency range. And this is important because with the increasing importance of electric vehicles, where road noise is a much higher percentage of your total noise when driving, there's going to be more and more focus on reducing the amount of noise. And if you've ever ridden in an electric vehicle, it's definitely true. You really notice the road noise a lot more. So here's a quick comparison between the existing acoustics wave model and the new perturbed convective wave model. The top 2 graphs show noise measured, I think, on the surface of the window, and the bottom 2 measure noise probably somewhere around the driver's head. And you can see with the existing wave model above 5,000 hertz, you have an increasing dependence on mesh resolution. As you can see, the yellow line represents a coarser mesh, and then as you move down, the red line represents a more refined mesh. So you can see, in order to have a converged simulation, especially in the high frequency range, you need a lot of elements. So with the new model, there's a much reduced dependency on your mesh resolution, which means you don't have to use as high of a mesh resolution with the new model. And this ultimately results in a 2.5 to 3x speed up for these simulations. All right, the next thing is simulation templates. And templates have always been possible to create, but there's never really been a system for them. Whereas in the past, you really just have to save a SIM file and then kind of name it your template. Now you actually have a SIM file extension. So the concept has really been formalized in this version, and there's even a save to template button here to help avoid saving over a template that already exists too, because I know that can be frustrating, and I've done that before. So the benefits here are you have a more robust and reproducible workflow that allows consistency for the users and the organization. You can have increased trust in simulations due to reduced human error. And then you can also deploy best practices in your simulations and easily update and transfer knowledge when necessary. All right, the improvement to fluid structure interaction that I mentioned earlier is the addition of contact with tessellated geometry parts and the ability to handle those now. So basically what this means is you can have a structural part that may contact and deform against rigid parts. And this is a big step forward in the contact roadmap within the Siemens development team. So basically, this is probably best explained with the picture. This gray piece and dark black piece fit together, and there's a deformable gasket or seal kind of between the two. And the seal squeezes the assembly, but it also serves as a check valve for the cleaning liquid in this. I think it's a automotive camera valve to help clean, I guess, camera lenses. So I actually have an animation here. So you can see the two pieces, and the yellow piece is the seal / valve. And the two pieces are moved to compress the seal and the valve, and then the fluid simulation is activated. And it is important to note that the shape of this seal / gasket is actually different from its shape beforehand. So the simulation is actually critical to showing the actual function of this assembly. And if you didn't catch it, basically the pressure load opens the sleeve and the flow path, while at the same time the outer surface of the sleeve is being pressed against the rigid nozzle. So this is something that you previously could not do in STAR-CCM Plus. Okay, so the next big feature is the SimCenter STAR-CCM Plus Web Viewer. Now this is really exciting because it allows you to share scenes to someone without any type of access to STAR-CCM Plus. All they have to have is the scene file. And the easy thing about it is you can open up your browser, go to this link, and it brings up the web viewer, and then you can point the web viewer to your scene file, and it allows the user to open up the scene, interact with it, and view several different scenes to look at the mesh, the geometry, or different volume rendering methods that have been exported from STAR-CCM Plus. So this makes it easier to share data, but it also allows you to share more insightful data than usual. For example, this is going to be a lot better than just showing a picture or a quick animation, because you can actually spin the model around. And yeah, there previously was something called the STAR-CCM Plus Viewer, and I think it definitely still exists, but you also had to have access to be able to download that and install it. So this is something that you can run completely without any access to STAR-CCM Plus or some viewer that you have to install. And there is a quick video that kind of shows how this works. So you can see all you have to do is go to this web page. There's a couple buttons on the left for opening scene files. And then you can see here, we're basically visualizing the geometry of a combustor model, but you can interact with it. You can zoom and pan and rotate around. reset the view if you need to. And then you can also visualize mesh scenes. And there's a lot of support for all the rendering types, such as surface and volume rendering. And you can see here, you can spin the mesh around. You can look at different post-processing scenes, such as something like this. And then you can also look at 2D plots, such as something like this, where it's like a residual. And the cool thing about this is you can see it automatically scales the axes for you. And then, yeah, you can also look at just different monitors and reports. And then just one thing to note here is that this is best run with Google Chrome. I haven't tested it out with any other browsers, but it worked fine for me in Google Chrome. So the next cool update is the modified high-resolution interface capturing scheme in the volume and fluid method. And basically what this does is it helps you resolve the free boundary between a multi-phase flow, such as this gas tank with a liquid and a gas in it. And previously, the high-resolution interface capturing scheme, it was actually getting a little bit too good, especially with the adaptive mesh refinement that SimCenter STAR-CCM Plus has introduced. It's been really, it's been a really good feature for speeding up simulations. And something like this, where you may not really want to resolve some like the droplets and bubbles and like very fine flow structures, you can actually add computational cost back into your simulation. It kind of can swing a little bit too far. So this is kind of like an adaptation that Siemens has introduced, where it kind of smooths over some of those more spurious results, especially if you're not super interested in those details. So these two models are both available. They're just, it's kind of left up to the user to decide how much detail they want. And another detail here is that it removes the need for tuning factors, so it can, it can help convergence of your simulation and lead to more consistent results and overall speed up your simulation runtime. All right, the next thing is kind of in the same vein. It's a new implicit volume of fluid multi-step method. And this is kind of complicated, but the gist of this is instead of running a lot of fluid time steps, you can increase the amount of volume fraction sub time steps. And this is actually a more efficient way to run this this simulation. So and that's because the volume fraction substep is a lot more computationally cheaper than the flow time step. So you can increase the substeps, decrease the time steps, and arrive at the same answer, but just a lot faster. And you can see for a single step versus a multi-step, you have a lot of the same output variables. You have a very low difference in these output variables, but you have a very high difference in your simulation time and simulation steps. So this is a good way to speed up a simulation like this. All right, let's dive into some of the miscellaneous updates. The first one is one that I think is kind of cool because it's something on the back end that just improves the meshing capabilities, but basically the meshing algorithm has been updated to merge patches in a little bit better method so that you don't end up with like a janky looking mesh like this, and you can end up with something more similar. But I find this kind of cool because it doesn't really require any, any extra thing you have to enable on your end. It's really just automatically included. The next thing is actually something that's really cool. You can now much more easily produce a labeled point probe. So you can see here, it's really just with a click of a button, you can actually label parts of the data. And I think previously this is definitely popular. It's just far more easier because it's actually in the menu bar. And it's probably also streamlined within the derived parts menu toolbar. or model tree. But yeah, obviously you can see here too that you can change the actual field function that's displayed on each annotation. So if you want to annotate like multiple data points, even though you're only showing like pressure coefficient, for example, here. But yeah, it's basically a lot faster to create those type of annotations. So this improvement, the center of loads report, is actually something that was introduced in a version or two ago, but I did want to highlight it here because I think it's actually really helpful. Basically, it returns an intersection point of the line of action on your resultant force due to the fluid flow. And the improvement actually for SimCenter STAR-CCM Plus 2022.1 is that it's an improvement that lets you run half car simulations or half model simulations a lot easier, because previously the center of loads report wouldn't really understand that the model is being run at a half model. So now with 22.1, you can see the center of loads report is actually in the right spot on the car where you would expect. And there's a checkbox. Oh, I think that was too far. There's a checkbox down here. Where is it? Oh yeah, account for idealization. And this will tell 22.1 that, hey, I'm only running a half simulation, so take that into account when summing up the center of loads. It just makes this a much more easier process for a half car or a half vehicle simulation. So the next thing is the user interface distinguish body color. I think I've actually used this recently, but it basically it allows you to view different bodies easier, especially if there's a lot of different ones that are all close, and the standard Siemens color palette may be a little bit too pastel-y, so you can switch to a high contrast color that helps you differentiate different parts. And the last slide here just kind of highlights some of those other changes in that, and the more detailed what's new presentation. But a very small change for the actual tree is that the icons have been switched out so that they're more intuitive and it's not confusing. But that's a really small change. Obviously, the part visibility has changed as well, but they've actually made some improvements to the meshing side of things as well. For example, you can do a multi-surface extrude now, and then the TET/poly mesher has been actually improved a lot. In some cases, the meshing process is 4 to 6 times faster, especially with the adaptive remeshing. And then also with morphing or remeshing, the adaptive meshing is now compatible with that. In terms of physics, there's a lot of improvements, so I kind of had to just pick a few for this presentation, but I know for heat transfer, there's improvements for non-participating media for radiation simulations. And then the AMR capabilities are now compatible with Eulerian and dispersed multi-phase simulations. And then there are also improvements to Lagrangian multiphase and DEM, rheology, reacting flows, and electrochemistry and electromagnetics, and then improvements to solid mechanics. And then there's a lot of improvements to the data analysis capability of STAR. So that's it. I try to keep this webinar kind of short because there's a lot of different features, but I hope this gives you a kind of an overview of the big ones that could save you a lot of time and make your life easier. Definitely go check out the detailed features list, especially if you're a power user or you didn't see anything that was really here for you. The list is huge, and I had a hard time just getting through the whole thing. and it seems like there's something for everyone in this update. So anyway, that's it for today. If you have any questions, feel free to reach out or enter a question in the chat. I'll go ahead and look at some of those. But if you have any questions or would like to see a demo, feel free to contact Keith. He's our Director of Sales. Yeah, that's it for now. So I'll give people, a few minutes to type out some questions if they want, but that's all I have for today. Thank you for tuning in, and we'll probably be back on in another few months. I think the release cycles there's 3 releases every year. So we'll have another What's New webinar coming out in the next few months.